engineering for the opportunity to do this. I think I addressed this seminar group maybe 5 years ago or so, and it's always, I've sat in on some of them. It's always a wonderful institution within itself. So today I'd start with, I want to talk about transportation economics. That's what I do. And it's partly how does it figure into your careers as engineers? And so economist comes up to you. The project is uneconomic. What does it mean? What do you do? And so today I want to talk about how the disciplines of engineering and economics interact with each other. I want to introduce some fundamental concepts about economics. And at the very end, I'll provide some examples of using economics in some contemporary issues. Economics applies because the two of you, the economists and the engineers, are always working together. And you have different roles in a project team. The economists are worried about the demand and the cost of the price. Economics generally is looking to decide what should we build. Engineers come in and provide the engineering dimension of operating costs, technologies, practices, and how should we build things. That's productive efficiency. And an aspect of this is how different private and public employers are, whether you're with a company or a private consulting firm, or a consulting firm doing work for a government. The private sector is that part of the economy that is almost tautologically we have set up to be an independent functioning part of the economy. The government doesn't tell a private company what to do. We do set up a legal and regulatory framework that lets the private companies carry on and do their thing. They're concerned with finance, financial feasibility, and in a sense, both allocative and productive efficiencies are co-evaluated in the private sector. The private sector will use economics for some price forecasting, macro conditions, but that's not part of the feasibility in the private sector. Private sector, if it makes a profit, go ahead. And various jurisdictions, of course, organize what's private and what's public in different ways. But in the public sector, it's the part of the economy that sets up with active government participation within some sort of governance framework. And public sector is concerned with where it's difficult to isolate users or specific benefits. In other words, health, education, public safety. These are all things where it's difficult to isolate how much benefit did one individual get from the fact that we have a functioning legal system. And so we're not trying to isolate benefits that way so that we can charge user fees. Sometimes we use a user fee, and we get into hybrids. But in the public sector, you have to start with an economic analysis to look at the overall social benefits, the overall social picture, before you decide how to fund it. And that's the big difference with the private sector. The allocative and the productive efficiency estimates are separate, and there's a much greater role for economics in the public sector than there is in the private sector. It's wrong to dismiss economics as meaning private profit. I think there's a mixed up about what economics means sometimes. Just looking back on the history of the last 5 centuries, science has reached into more smaller and bigger things and greater levels of abstraction. We've gone from putting the sun at the center of our universe, our cosmos, instead of the Earth, up through the various centuries that you see described there. In the 19th century, we change our sense of what are humans in the sense of time, geologic time, evolutionary time. And then in the 20th century, we get into social sciences, psychology and economics. The 21st century, the big task for us, of course, is sustainable development. And the Brundtland report kicked off a whole lot of thinking about sustainable development in a very holistic way. There are 3 up the ideas around sustainable development, that you have ecology, economics, and society, and that all 3 of these have to be considered in a complete way and in an integrated way in order to have development or activities that are sustainable in the long run. And of course, the topic is climate change. The issue here for transport is that there's a cap on the absolute amount of carbon, tons of carbon, that we can have in the global ecosystem. And as our population around the world continues to grow, and as incomes grow, people demand more things, the only way to reach a fixed cap is that each individual activity, or each individual person, has to consume less carbon. And so efficiency is the parameter which lets you have more people and more life, and at the same time keep carbon. And if we're going to have efficiency, then we cannot afford to make inefficient investments. That comes back to an economics perspective. I like the Greek word ecos. Ecos means house in the narrow definition, or it means the place where we live in a broader definition. Economics is about the management of the house, and ecology is about the science of the house. And so there's a connection between managing without waste and minimizing our ecological impact. Economics is often described as meeting unlimited human wants. In other words, maybe not necessarily wants in terms of quantity, but certainly quantity plus quality results in people wanting more and better stuff. So you want to make it efficiently, and then you want to distribute it fairly. So that's the second dimension to economics. The nickname is, of course, the dismal science. You can't do everything you wish you could do. Economic analysis hits various levels. What we're going to talk about later on is down at the project level, where we're talking about cost-benefit analysis. But as an engineer, you might be asked to work in an industry, in an agency, for a government, for an advisory consulting firm, and you will end up working with people who are dealing with growth rates and competition questions and productivity questions. So it's important that in engineering to have a sense of what's the whole picture for the economics world. And economics is about resource allocation. Well, resources, the classic three were always labor, capital, and land. Land tended to include the idea of natural resources. But more recently, I think we can legitimately add location, information, time. Sorry, this has an error. The word time is not there. Management, attention. These are all resources in the broad sense, of which there are limited amounts and which we have to allocate. There we go. And the other topic that comes up from time to time is the word need. There is no such thing as need in economics, apart from actual literally subsistence existence. When you hear the word need, it's because someone is trying to fudge what's the demand. They're trying to suggest that we don't need to consider demand very much because there's a need. In reality, demand is exactly what we want to consider. So there's a dichotomy between microeconomics and macroeconomics. This wouldn't be an economics presentation if it didn't have, on the left there, a graph of supply and demand. And on the right, a joke about the dismal science. This is from the European crisis of, 10 years ago, where economics is leaning in as the Grim Reaper and bringing a different perspective on how Europe should be functioning. Microeconomics deals with welfare. Welfare in the sense of it is used to mean utility and how people's preferences are expressed in demand curves. And micro is really down at the level of an individual and the benefits of behavior and activity to that individual, what they buy, what they sell. And then you aggregate micro up to the level of households generally, and from firms to industries. But that's as far as it goes. That's the largest scale that you get in microeconomics, is the whole industry, the whole population of consumers. Macroeconomics is an idea that developed in the early 20th century because micro wasn't dealing with big picture issues of full-scale employment, inflation, and those sorts of things. In the transportation economics world, we look at micro because it's focuses on the specifics of a project, the exact travel times you get from running a particular service, the exact costs of both capital and operating and rehabilitation. Macroeconomics is about the GDP, it's about the big picture stuff. Modeling in macroeconomics is done through large simultaneous equations models, which are closed. They are a full equilibrium model. So if you change one part of a macro model, you change the labor force participation rate, for example, goes up a little bit. So the price of labor gets cheaper, but then that ripples all through the economy. Okay, if labor is cheaper, what does it mean in the manufacturing sector? If manufacturing changes its inputs, what does that mean back in the resource extraction sector? And what comes out of GDP analysis is a multiplier. And in our world, people talk about multipliers as if you invest in this highway, you'll generate so many jobs. Well, it's not useful because it's just if you spend more money, you have more jobs. And it's not useful for choosing one project over another. If that was your only metric, you would always be choosing the largest project for which you could feasibly get approval. The other thing about macro is that people tend to use the multipliers naively without understanding that you also have to raise taxes to pay for that expenditure. And so that's the negative side on macro, the correspondence to cost, in cost benefit, that may get ignored. OECD, this is a fairly standard presentation of what is dealt with in a microeconomic cost benefit analysis and what gets dealt with in GDP analysis. And there's that overlap in the middle. No one tries to disentangle this and do a crosswalk between the two. Typically what we want to do is stay in the microeconomics world because that covers it well enough. And I come back to a point about accuracy over precision. Yes, and so that first dichotomy was micro and macro. This second dichotomy is about economics and finance. And so economics and finance both use the word dollar. The dollars mean very different things, and they cannot be added, subtracted, or manipulated together. In economics, we really do value accuracy over precision. You know, a couple of economists can have a conversation about topics where they're just using it to not even three significant figures, you know, two figures, and picking approximate numbers out of the air and then having a discussion. The important thing is that it be a complete discussion rather than that we have narrowed down to some level of precision. Another trick here is that economics has no professional designations, unlike engineering or finance. There's no generally accepted accounting principles or generally accepted economic principles. We have evolving practices, but there's no appeal to a court or a professional standards body about how to apply it. So in traditional, conventional transport economic cost benefit, you see the costs are what we normally think of as costs. The benefits are travel time, things like vehicle operating cost savings. That would be for example, the cost of you operating your own private vehicle, your own car, for example, your own bicycle. The cost of operating a bus or a train up under the operating costs line. So these are the benefits are all users, or more broadly, safety is a cost to all of society, and GHG savings are also a benefit to all of society. GHG is also a benefit to all of society. And when you compare these two, what you get is a surplus or a negative. It's not a profit. And I think one of the things to remember is that travelers do want to reduce their transport cost. And that's part of the reason why travel time benefits are a huge part of this. Financial, on the other hand, the cost structure is very similar. It's the benefit side which is quite different. And now financial transactions are market transactions or exchange transactions. And it's from the point of view of who owns what. I own my own labor and I exchange it on the labor market for money, financial money. It's in current dollars. And if there's a benefit out of all of this, we call that profit. And so really the main difference when you look at the economic CBA and the financial CBA, you'll see the difference is in the benefits side, not the costs side. And so there we back to sustainable development. We're talking about microeconomics now, and the other thing I want to introduce here is the idea of a partial equilibrium. Partial equilibrium is focusing on the specifics of the project rather than the economy as a whole. In partial equilibrium, we assume a functioning economy out there. You've got a functioning manufacturing sector that makes concrete, and a logistics sector that delivers the concrete to a construction company who then builds your bridge or whatever it is. And that you're building that bridge with a good design, a functional design, that you're building it to a standard of ecological, reducing ecological impacts. It's safe. So all of that is assumed already. You've just done that. And that's all baked into your cost numbers. So it's the cost of building an an environmentally good busway. And then you do the ECBA itself, and you figure out how much demand there is, and blah, blah, blah. And if you build a project, you've saved so many minutes. And so that's the output. The output is minutes of time saved, or vehicle kilometers not run. And again, we don't try and follow it through the way you do in a macro model to say that we saved 100 million minutes in Toronto out of 2 million people, so everybody got 50 minutes a year to spend. We don't tell you whether they spent it on leisure, they spent it on work, they spent it on whatever. That's not of this analysis. So we assume everything comes in, the project happens, and then everything goes out. Here we come back to a classic supply and demand, and S1 is the transportation corridor before you build the facility, and S2, the supply has increased. And what's happened, therefore, is that the price to the users has gone down from P1 to P2, and the amount of demand has gone up from Q1 to Q2, a classic sort of supply-demand calculation. And you see that in our transportation modeling work, P in this case means number of minutes, or number of vehicle kilometers, the money spent on the vehicle kilometers. And when the new facility was built, all of a sudden your travel time improved, and so the effective price to you went down, and you may end up more time traveling. You may end up spending, as I said earlier, you could spend that on leisure, you could spend it at work, you could spend it traveling a longer distance to visit different people or take a different job. The limiting problem here in the Toronto area is that up until now, we are working with a fixed amount of population and employment in the future. So in 2041 or whatever it is, we have so many people, so much employment, and we are not changing that according to how well the transportation system is working. If Toronto doesn't build much, it's very congested in 2041, has the same population and the same employment in total as it would with improvement. Now, what we do is move it around. The control total stays the same, but it does move around, and we reallocate it to typically a single land use scenario. But what it means in the economics world here is the global demand for the whole region is fixed. And so really, we're only dealing with the blue portion of the cost-benefit analysis calculation. The mechanics of cost-benefit. Well, you've got to set up a business as usual for the horizon year, say 2041, without the project, and then you do it with the project, and you see that the world is different under those two scenarios. What changes is time and vehicles, and we take those time and vehicles and show them project opens and behavior happens for the next couple of decades. You have hopefully an improvement in travel times, and you had some capital cost at the beginning. These are all brought back to a single value called a present value, which is what a discounted cash flow does. And when you compare the cash flow present value of the cost, the cash flow present value of the benefits, the two of them give you the net present benefit. Now, you can go around the world and get different ways of doing business cases, different ways of accounting for the costs and the benefits. Metrolinx has their way of doing it. City of Ottawa had their way of doing it. I don't know, Cape Town in South Africa has one way of doing it. We can get into a long and somewhat academic debate about the details of how to value each little piece of it. It's more important that when you do an analysis in a given region, in a given location, you're using the same set of parameters for all of the evaluations you're doing, so that back in that partial equilibrium, the little yellow blob is being done consistently. The other caveat here is if you are unduly pessimistic, you can overstate project benefits. And that's just a caveat on the whole thing. We really need the engineers because you really need a network-wide travel demand model. It has to incorporate all the minutiae of that network assignments. The network that's underlying the modeling is critical because people behave critically, and we're back to this is why it's the microeconomic analysis. Only two inputs I want out of the model. One is the total travel time, and one is the vehicle kilometers by cars and vehicle kilometers by trucks. And yeah, that's 3 numbers, and I want it in the base case, and I want it with the project case. So that's 6 numbers. And from those 6 numbers for each horizon year, and ideally you would do it for several horizon years, and for each things like a different land use scenario, combinatorically you get up to quite a number of different runs of the model. But from each run of the model, there's basically 3 numbers that I want. So that's why I call this the macro geography is the microeconomics, where you need, you're synthesizing the nature of the spatial economy into those numbers. So economic value depends on this time savings, the vehicle resource. Ridership numbers get quoted all the time in the press, and they are irrelevant to the economic cost benefit. Ridership on a segment, ridership, new ridership, transit ridership. From the economics perspective, you've got X number of people, Y number of employment, Z amount of travel. Whether you're moving on mode A or mode B doesn't change the fact that you have a functioning economy with people going to work or going to school or whatever they do. So we're getting the benefit of their employment, the benefit of them being a student, the benefit of them having social interactions is what we're measuring for the economic benefit of society. Your individual choice of which mode you take doesn't change the fact that you're a worker. Now, what it matters for is the amount of resources that we assume the project is going to have consumed. And we're back to that question, what kinds of resources? And that's, land, capital, labor, time, etc. So the focus here is on the society over the whole travel network for all kinds of travel. Trouble with partial equilibrium is it doesn't optimize. It's not mathematical optimization. It's not any sort of programming analysis. It's a snapshot. It says if you build X, this is the travel pattern that we'll get. If you build Y, we get a different travel pattern. So you have to explore a whole range of things in order to see what's the best kind and level of transportation services to provide for this location. And then we also have to do those numbers I mentioned. That it's a small number of figures coming over from the demand forecasting model, but then we play with it a lot. We play with the cash flows. What if it happened faster? What if it happened slower? What if the costs were 10% higher, 30% higher? So there's a whole lot of sensitivity testing that has to go on with understanding the demand that's come out of the model. And Vucek at Penn was, to me, summarized it best when you talk about route from service. So you have to be looking at different routes to solve the problem of travel from the travel from York region into Toronto. That's the problem. And there are different routes that could be used. On those routes, there are different technologies that could be used. And with each of those technologies, there are different levels and types of service. So that's what it means when I say alternatives. I mean looking at all three of those aspects. From the World Bank work, they have an operations manual, and it's not a guidance document. It's not hundreds of pages. The official rules about economic cost-benefit analysis occupy a half a page, and it basically says two things. You can't build projects that have a negative net present value, and you must have looked at mutually exclusive project alternatives. That's it. And they sort of assume that they've hired competent staff or competent consultants who know how to do all of this. But those are the two decision rules, positive NPV and alternatives considered. And so here we have the economics on the left, with in the yellow some costs, and in the green some benefits. And in principle, what we're doing is looking at a project that has a surplus, economic surplus, and that means that all of society has more resource to spend. Over on the right-hand side, again, sort of a typical transit project in Canada, where the financial benefits of revenues does not meet the cost. And so you want to have created a project that created surplus so that your economy does have money to then spend on the financial support. If you have an uneconomic project, you've had double losses in a sense, because you've shrunk the economy. Your negative number means the economy's gotten smaller, and now from that smaller economy, you're trying to extract tax or user fee to provide as a subsidy. I'll touch a little bit on equity. Cost benefit uses a society-wide average value of time. So it means that if you're a poorer person, your trips are valued up to the average. If you're a richer person, your trips are valued down to the average. So we're working with the representative common person. Again, we're looking for accuracy over precision. I'm not trying to understand the segments of society of analysis. I'm trying to say, broadly speaking, what does the travel benefit or the vehicle cost savings mean to the average person? And you also see questions of, well, if we build subway X or busway Y, this neighborhood will benefit. And the point of using a whole region-wide model is that we're trying to get the whole region-wide benefit, and we're trying to see those interactions between improving one corridor having a spillover effect or a ripple effect on how it affects travel in other corridors. So it's not just that you build the line and Flemington Park wins, and it's not like everywhere else in Toronto loses, because that line also stimulates benefits people beyond the end of the line. For example, the Scarborough subway extension to Scarborough City Centre. It's not the number of people who are riding the subway that matters. It's the number of people in Northeast Scarborough whose travel time to downtown changed. And you may not, in fact, be close to the subway station. You may have up in Malvern, which isn't all that close to the proposed end of the line, but your travel time to downtown will change quite a bit. And finally, the whole thing about economic surplus is that if you've grown the economy, we have more resource to do many things, not just subsidize the transit. So February last year, Metrolinx announced 2 business cases for the Scarborough subway and the Eglinton West LRT. And this CTV reported it at the time as costs, so they correctly said the costs exceed the benefits. And the politicians responded with, well, don't worry about it, because this investment will stimulate a huge number of jobs. And the other quote was, we're not building transit on the basis that it should be profitable. Well, you've actually mixed up two of the dichotomies I described earlier. First of all, this is in microeconomic terms, not macro. The jobs are at cost. If you could wave a magic wand and this project happened with one's effort, that's what you would do. If it takes 10,000 people's effort, it's not that the job was done better to employ more and more labor. So, the fact that this is a huge number of jobs simply reflects that it's a huge project. It's not a way of saying it's a good project. And secondly, we're not trying to show a profit. We're trying to show an economic surplus. And as you saw earlier in the little graphics, the point of generating is to have money to pay for things. We certainly did not and never did expect a profit. And so that's why the World Bank prohibits lending to projects with a negative net present value, because you shrink the economy. And I think generally speaking, the public and the media have a hard time sorting out what these different things mean. And finally, I'll come to the Eglinton Crosstown West extension, which has the worst results of any of the projects that are going ahead at the moment. And so I'm using that as my example, testing alternatives. So I think the one they're going ahead with, the net present value was about negative $2.9 billion. So you're going to spend $5 billion, you're going to shrink the economy by $3 billion. It's at a time when we're dealing with post-COVID, we're dealing with fiscal pressures across government. Spending money to shrink the economy doesn't make sense. And where you see this here is I put out two different alternatives. One is, if you have to put something on Eglinton, why is it not a busway? You've got a huge right-of-way. You have someone in a report a year ago saying, well, now 2 years ago, saying, oh, there's a transfer penalty to get on from the LRT onto a bus, therefore we won't consider this alternative. Whereas in reality, you could get on an express bus at the end of the line, like you do currently at Kipling, and ride on your busway pretty quickly into the airport. And perhaps what you should be spending the money on is, the bus will be connectors that will let you go from the highways into the airport terminal facility efficiently. That would be costly, but certainly not the $1 billion of this tunneled LRT on Eglinton. So if on Eglinton, why not a busway? And if you have to tunnel it, for some reason you think you must do tunnels, then why not on Dixon? And you see it there, my example of Dixon is in red. Stylized, I've added the Pearson Airport main runways, and in the blue ovals, the flight paths for those runways. The historic connection into the airport has lots of existing commercial activity, business activity, retail activity, hotels, which are all being ignored by this new, the Eglinton extension. So to me, it's a failure of looking at alternatives. There were alternatives that could have been considered. No one did them. So some economist comes up to you and says your project is uneconomic. It's not an indication of nothing. It's think more deeply about the problem you were trying to solve. It says that the supply and demand are out of balance. Typically, you're putting in too much supply. You need to examine the route, the technology, the service, and that's particularly where the engineering comes in, is the technology and the service. I think I said it earlier as well, that's your role, is to tell this project team, this is what we could do. Engineers like to build fancy stuff, complicated stuff, freeway interchanges. And that big fancy stuff tends to be expensive. Expensive is not a bad thing if it's also balanced with a huge benefit. So you need to be open-minded about the alternatives. And then you have to model it a lot. As soon as you say, we have four different, very different service scenarios, 4 different routes, 2 different technologies, 2 different levels of service. What are we up to? 4, 16, and 2 different land uses. We're up to 32 combinations right there. and two different growth rates, 64 combinations. But throwing money into the modeling now is the only way to see that you're not losing billions in your economy down the road. So they really do have to do a lot of work on this. If I was selling shoes or chocolate bars, things in the typical consumer retail markets, companies spend a lot of time on estimating demand. And here we're dealing with massive amounts of money for massive infrastructure that has critical implications on people for decades. But we do a relatively quick couple of scenarios that don't test much and spend a lot of money. So I think there's a real problem with not spending, it's an unfortunate metaphor now, but it's spend modeling resources like water. That's not, so in the 21st century, we can't do that with water. But go ahead, model it 64 times, and then look at the results and think about what that means for the corridor or the region that you're dealing with. And finally, I think that when you have a project that has, you go through all of this and you show it has a positive net present value, positive economic surplus, you tend to be looking at projects that people see intuitively, they grasp that it makes sense. It's the uneconomic projects where there's a dissonance and people go, oh, that doesn't make sense. So I think you'd have a better, you'd improve credibility of the transportation sector's management and decision-making and all of us who contribute to that by doing projects that made sense. And one way test for that is, does the project contribute to the economy or not? So that's it. I'm very happy to entertain questions. Now, at the moment, I'm only seeing my PowerPoint screen. I'm not seeing the chat or any other people. So if Mustafa can direct questions to me or reiterate them, I'd be happy to answer them.
Thank you so much, Bill, for your interesting presentation. Yes, so if you have any questions, audience, you can use the chat box or you can turn on your audio and have a discussion.
Yeah.
Well, Bill, it's Brendan, since I'll get the ball rolling.
Okay.
Good presentation. I really like your emphasis and distinction between alternatives analysis and cost-benefit analysis. I especially, we both have experience in the US and Canada, and you have a lot of experience abroad with the World Bank. I've always thought that the MPO model in the States with alternatives analysis, the focus is on alternatives analysis heavily before you do any kind of detailed project evaluation, is in total contrast to the benefit case analysis process that Metrolinx uses, which is modeled on the sort of English model that you basically narrow down things first, then do a detailed benefit cost analysis, benefit case, because it's got a lot of qualitative factors you're looking at. But the main purpose is to make sure you're not investing in a real dog of a project, as opposed to trying to find the best alternative for, the whole corridor, the whole area region that you're looking at. And I guess what's, if I put it in those terms, what's your reaction?
Yes, I think that's a very useful distinction between the actual cost benefit and the alternatives analysis, because you really must start with a blue sky of alternatives. Sometimes I think the word plan is the wrong thing to have for a 30-year horizon. You can have a design, or you can have a different design, but the plan sort of locks you into thinking. To me, it's a land use planning concept, that if we put red dots here and blue lines there, that's how the universe will unfold. Design to me implies more, many things could happen here. And looking at the alternatives is the way to begin.
I guess it just to follow up that I think that's something that's missing in sort of the Toronto context. So we don't really have a process, and it should be multimodal as well. I mean, with the separation between MTO and Metrolinx, there's sort of built-in silos. But in the alternatives analysis approach, you're looking at all modes as alternatives. Whether it's expanding highways or putting in new transit lines or just improving operations. It's a much more multimodal approach to design.
Right. And to me, the other point here is the partial equilibrium. Like, I like partial equilibrium for project level analysis. I want to focus on the cost of running a kilometer of the bus versus a kilometer of the LRT. That's great. But I also, this is all within a sector policy. Do we have a good sector policy? Have we assigned the institutional roles properly? Do we have the correct level of road user fees? Do we have a good level of carbon pricing? Do we have a good level of minimum wage rate? There's all sorts of, in this partial equilibrium, we're taking as granted all these other factors, which also have huge effects on the transport sector. So I don't think cost-benefit analysis is by any means the full answer. I think it's an important part of the economics part of the sustainability triad. And I think it does give you a red light. If you're showing, among a set of alternatives, some of them are negative and some of them are positive, it should be fairly straightforward to reject the negative ones.
Except for, as you pointed out, that even that doesn't happen.
No. And so in a little bit, I don't, this is where I'm, a technocrat, I don't quite understand how the media don't jump on it, and how, it's fairly easy, I guess, for the politicians to deflect a technical answer.
Yes.
But,
Thanks.
Well, thank you.
So we have Amit in chat box saying, thank you for the excellent presentation. In my experience, road widening projects always pass the ECBA test, while road safety roadway improvements for vulnerable road user fails. How can economics help gather the political will to undertake cycle path safety and improvement project?
Absolutely. There's another whole part of project analysis called cost effectiveness analysis. So this is cost benefit analysis. To do this, you have to be able to identify benefits. And so you identify the cost, you identify benefits. In the cost side, we've assumed a whole lot of standards. If you think a road safety standard should be that we have a sidewalk, for example, or the road safety standard is that we should have 1.5 meters of bicycle lane on every arterial road, that would be, so there's two ways to answer your question. One is the standards setting, and absolutely that must happen. We have engineering standards to prevent things from falling down or breaking apart. We should have engineering and planning standards that say we build a cycle path. We build, your traffic signals have to have certain amount of green time for the pedestrians. So all of those technical standards need to evolve and include all the users. And then once those technical standards are set, that's how we design the project. So we're only building projects that have a bicycle path. We're not building any projects that don't have a bicycle path. But then the other one is simply cost effectiveness, and we say this attribute is a standard. You are going to build it no matter what. I'm going to for the construction company to build a bicycle path. Now we just make sure we have an efficient procurement system and efficient construction to build that bicycle path in the least cost way. So cost effectiveness is about build the thing you want, say we want it, and now we're going to build it as efficiently as possible. I guess they both come down to determining a standard or a willingness to build this thing. And that gets you into the political realm, which is sort of the social part of, which is part of the social part of sustainable development. I'm a big believer that all three of those triads, the ecology, the society, and economics, have to work. If you put up 3 traffic signals, they each had a red, green, and yellow light for each of those 3. I would say that any one of those 3 has a veto. So that if you're on the economic side, if it was a negative net present value, you get a red light. I'm sorry. And if you get right on the borderline, perhaps it's making a surplus, you get a yellow light. And if maybe 2 of the 3 are yellow, it's also a veto. So if society wants standards that include certain kinds of road safety, we have to, society has to build that into its plans.
Thank you so much. So we have time for one question, but I'm sure Bill is able to stay online if you have any question afterwards. So we have another question from Tamara. Thank you for presentation. You mentioned about modeling, multi-modeling, how we should rely on the result of multi-modeling without specific testing of those models on real economical results.
Sorry, could you repeat that, please?
Yes. You mentioned about modeling dash multi-modeling, how we should rely on the result of multi-modeling without a specific testing of those models on real economical results.
Okay, so when you're doing the classic travel demand models, whether it's the old 4-stage model or Eric Miller's newer models, you're working from survey data, sometimes the regular surveys like the Transportation and Moral Survey, sometimes from very specific surveys to gauge people's trade-offs between travel time and public transit fare and price of operating your vehicle. So you've done there's a whole lot of underlying economics in the travel demand models. It's all based on the transactions that happen and the choices travelers make about when and how to travel. So there's a grounding. It's well grounded is what I'm saying as a starting point. When I do cost benefit analysis, I am not using transactions values. The transactions values are like the financial ones. Actually, we used to get into, when I worked at MTO, we would get into discussions with Metrolinx on this, that they were arguing that you should take the value of time that's implied in the travel demand forecasting model and use that value of time for your economic analysis. And the distinction is that the value of time in the forecasting model is a transactions derived value. What I'm doing is picking a whole of society value, and I, when I update this to send it around, I'll put in some bibliographic references. But it's a whole of society value. It's not a transactions value. So it's well grounded. The economics is different from the finance. And then the other thing is post-project evaluation. I mean, we should be going through and saying, when the Shepherd subway was extended or was created from Yonge Street over to Bayview, there should have been, and there could still be, a post-project evaluation. What did we think it was going to do? What did it actually do? And what can we learn from that about how we should change the way we do it for the next time? Now, Metrolinx actually has just come out with a, I think it's an RFQ for developing a post-project evaluation methodology, which is a very encouraging sign, very important, because I guess we had the Spadina subway extension open, and I don't think anyone did post-project on that one, and that's recent. So to answer your question about how valid or how we anchor this, that's the other thing to do, is retrospective learning.